Hello, and welcome to our first video for Chapter 10. So the goal of this chapter is to understand the roles of genes and hormones in the formation of reproductive organs. First, I want to connect the sleep chapter to the reproduction chapter, just to show you some similarities that we're going to see. So what are both sleep and reproduction? Thinking back to Chapter 3, one of the brain regions we talked about, we said that it was responsible for both sleep and reproduction because they were, what do we call them? What else is sleep, reproduction, thirst, hunger, fear? What are all of those? What do they all have in common? They're all vital drives. So now, do you remember that we call these all drives that are vital to survival? What brain region was responsible for these drives that were vital to survival? The hypothalamus, yes. So when we were talking about sleep in the previous set of videos, what area did we say helped control that circadian rhythm for sleep? The suprachiasmatic nucleus, or the SCN. When we talk about reproduction, we're going to talk briefly about the HPG system. That'll be more towards the end of the set of videos, and then also the sexually dimorphic nuclei. So now we're going to talk about what causes this prenatal, so this would be in utero, sexual differentiation. What do you think we're going to be talking about? Probably the genes or the chromosomes that are involved. And then what else? What else? You might not think about it prenatally, but when you go through puberty, what causes those changes in those secondary sexual characteristics? Yes, hormones. So our chromosomes is really where it begins, but the hormones do the rest. However, we've got to keep in mind that the hormones are controlled by the genes. And so it really is this kind of ontogenetic explanation. So what's the difference between the male and female chromosomes? So this is going to kind of, going back to thinking about a basic biology class perhaps, what we talked about earlier in the semester as well. So what characterizes the female chromosomes? They have two X chromosomes, yes. And what characterizes the male chromosomes? They have an X and a Y. And so this is just kind of showing you that. Here we have, this is the female chromosomes, and these are the male chromosomes. And we know that because we see X and Y here, and we see XX here. And this should just be a review from something we touched on earlier in this semester. Now, during early prenatal development, both males and females have what are called Mullerian ducts, Wolffian ducts, and undifferentiated gonads. Now, I've color-coded these here. So, Mullerian ducts, whose internal reproductive organs do you think they're going to turn into? Females, yes, that's why they're pink. And Wolffian ducts, whose internal reproductive organs do you think they're going to turn into? Males, that's why they're blue. So this diagram from your book shows the undifferentiated condition, again showing you that early on the fetus has both the Mullerian ducts, the Wolffian ducts, and the undifferentiated gonads, and then just kind of shows you what they turn into. So we're going to go into it in a little bit of detail in the next couple slides, but if you want to take some time to look over this diagram from your text, please do so. Before we go on to the next couple sets of slides, please make sure that you've downloaded this handout, printed it out, so that you can fill it out. There will be a place on Canvas that once you're done watching the video, you can snap a picture, scan it in as a PDF, type in the answers into a Word document, and submit that for a few points. So as we go, we're going to fill it out together, but I'm going to talk about some things and then we'll come back and fill it out. It's just going to hopefully to help you keep everything straight. So the male reproductive organs, do you remember which ducts we said were in the undifferentiated condition became the male reproductive organs? We have two choices, Mullerian or Wolffian. It is the Wolffian ducts. And those, again, are the precursors to the male reproductive organs. Specifically, they become the vas deferens and the seminal vesicles, but I'll tell you, just knowing that it's the male internal reproductive organs is fine. And just a little tip, it kind of is counterintuitive, right? You think Mullerian should be for males, but it's not. I think it's the opposite. Mullerian is for women, and the Wolffian ducts are for men. So it's the opposite of what it should be. So how do these Wolffian ducts turn into the male reproductive organs? So males had what two chromosomes? They had an X and a Y. And on their Y chromosome, they have a particular gene called the SRY gene. So the S stands for the sex determining region. Sorry, the S stands for sex determining, the R stands for region, and the Y stands for Y chromosome. So it's the SRY gene. So where do you think this SRY gene is? On the male Y chromosome. And its job is to turn the primitive gonads, so those undifferentiated gonads, into testes. So what are testes? So yes, most of the time students right off the bat say they are the sperm-producing organs, but they also produce some other things. Can we think, what hormone do you think that they produce that's more typical of males? Testosterone. Yes, so testosterone is actually a type of androgen. And so these androgens are going to increase the growth of the testes. And so as those testes grow, they're going to produce more androgens. And when we get to a certain threshold of androgens, that's going to cause those Wolffian ducts to develop into the seminal vesicles and vas deferens, or, as I said, all you really need to know is those male internal reproductive organs. So this kind of seems intuitive, right? We know that testes produce sperm, they produce testosterone, which is one type of androgen. What probably you don't know, or isn't as intuitive, is that they also produce something called Mullerian inhibiting hormone, or MIH. So based off the name, what do you think this hormone is going to do? It's going to inhibit those Mullerian ducts, because someone with an XY chromosomal pattern doesn't want those Mullerian ducts. They're going to turn into female internal reproductive organs. So this MIH causes those Mullerian ducts to degenerate, and ultimately the final result is the development of the penis and the scrotum. Okay, now make sure that you have that handout that I asked you to download and print out in front of you, because you are going to have to either, when you're done filling it out, you are going to have to submit it either as a JPEG, a Word document, or as a PDF. So the SRY gene, what did we say that it had its main effect on? What part of those undifferentiated organs? The gonads, yes. So the SRY gene affects the gonads, and what does it cause those gonads to turn into? The testes. So if you're looking at your diagram, you should be able to hopefully figure out what to fill in where on those boxes. It's the same positions that you see here on the video. So those testes then, we know they produce sperm, but what hormone do they produce? Androgens, and testosterone is a type of androgen. And then you can see here, so I have the testes producing androgens, and then I have this feedback loop, so that those androgens then make those testes enlarge, they produce more androgens, and ultimately then, what effect do those androgens have? What ducts did they have an effect on? The Wolffian ducts, and the Wolffian ducts then turn into those male internal reproductive organs, specifically the vas deferens and the seminal vesicles, but I said I won't hold you responsible for knowing this. Male internal reproductive organs is enough. Now, what else did the testes produce? We said sperm. Sperm's not on here. We said androgens. What was that other hormone? Mullerian inhibiting hormone, or MIH. So knowing MIH, that M stands for Mullerian, the I stands for inhibiting, H stands for hormone, then you know what the job does, right? It causes those Mullerian ducts to degenerate. So now let's talk about the female reproductive organs. So what ducts did we say turn into female reproductive organs? The Mullerian ducts. So they're the precursors to the female reproductive organs, specifically the oviducts, the uterus, the upper vagina, but knowing the female internal reproductive organs is just fine. So females, do they have an SRY gene? No, they don't. So do their gonads turn into testes? No. So the absence of that SRY gene allows the gonads to differentiate into ovaries. Do the ovaries produce testosterone? No, they don't. What do ovaries do? Their main role is that they're egg-producing organs, but they also produce hormones, estrogen and progesterone, which we'll see are more typical of females. So, they don't have testes, they don't have Mullerian inhibiting hormone, So the Müllerian ducts remain. So no testes, no MIH, no Müllerian ducts. So here again is that diagram from earlier that's from your text. And it used to be chapter 11, so that's why I just have an older diagram in there. But you can just see this undifferentiated condition, and you see those Müllerian ducts here turning into the female internal reproductive organs, those undifferentiated gonads turning into the ovaries. Here you see the Wolffian ducts turning into those male internal reproductive organs, and those undifferentiated gonads turning into the testes.